Hello everyone, how is it going? Welcome back to this course on fundamentals of data science. And today we are going to embark in this new journey of statistics and probabilities. As I already mentioned, almost 50% of your data science has to deal with the basic probabilities and statistical methods. From today we are going to learn some aspects of basic probability and statistics which are very key factors in data science. It's going to help you in a long run. So whenever we talk about statistics and probability, think in terms of data. So this is what we have for today's discussion. We are going to talk about what a sample or what is a sampling. Then we will discuss different types of sampling. Later on, we will see what is the probability and what are the types of probability in general. And by this course, in this class, you are going to consider and understand what a population, a sample, and sampling means and why it is important. And we are going to see some introduction to probability as well. Let's start with the first options that you have. Yes, before we understand about the population or the property of the population, we have this new term called statistical inference. So this statistical inference is the process of using data analysis to deduce properties for an underlying distribution of probability. The inferential statistical analysis infer property of a population, for example by testing hypotheses and deriving the estimates. Yes, it's a whole process in which we are going to consider various aspects of probability to understand the underlying distribution. So why it is necessary? The inferential statistical analysis concludes the property of a population. Statistical influence or statistical inference is helpful to identify the trends. It helps to improve the decisions we make. So now we have to understand more about how this inferential statistical analysis infers the property of a population. Here is more information. Basically, we have two types of statistical inferences. So we take that information like properties of population is one of the aspects of how we analyze things. So what happens is that from the population we take a sample, or in other words from the population data we take a sample data, and for the sample data you perform exploratory data analysis, and basically you are also using probability measures, and finally you are going to infer. And this inference that you make from the sample, you are going to map it to the population. So that's the key part. Let's look at briefly what are those two types of statistical inferences. The first one is statistical estimation. So this has a similar diagram here. We have a population, and from the population data you are taking a sample data from the population, and this data that is taken from the sample are used for making the inference. So you analyze with various methods and make an inference about the population. You just take a sample, but you're making an inference. In other words, just by means of using a sample data, you're deciding for the population. Let me give you an example. Say for example, in your school there are 30,000 students, and that is the population of the students. and among 30,000 I am picking say 2,000 students, and I am asking some questions like, for example, do you like to eat burgers? And if suppose say 70% students says they like burgers, what is my inference? My inference is that the whole population of 30 among 30,000 students, we would say that 70% of students like to eat burger. Yes, that is what it means when we make inference about the population. We are going to see whether this kind of inference is really reliable. Is it consistent? We will see some points on that matter as well. So the second part is statistical hypothesis testing. So you have data set 1, you have data set 2, and you're going to compare with a data set. You're going to compare these data sets for ideal models. And you have an hypothesis, you have an assumptions like you're going to compare this H0 with null hypothesis, and the correlation between the data sets are doubtfully agreed with null hypothesis at the threshold probability, and statistical significant data set has been applied. We are not talking about the entire scheme here, but I just want to give you a brief introduction of what the statistical hypothesis testing means. Well, if you go into deep into this hypothesis testing, yes, there is a huge lot of things you can study, and it's a part of statistical analysis. And if you are interested, you can go in this direction to understand more about the data, because we always use the data, and data are of course from the data sets that you have, and you come up with some hypothesis based on the data, and you try to prove this hypothesis. Either you can say, based on this assumption, you say that this hypothesis is true, and based on that you are making certain inferences. And finally you come to know that whether your assumption and hypothesis is really valid or not. Okay, here is the important question about population. We talked about population. Yes, population is a distinct culture of any organism or anything which has most one mutual features for reason of data collection and analysis. I gave an example of one mutual feature in case of student, right? Students of your school, they have some mutual features. They are all students. Different perspective has been used for population. If you talk about everyone in the school, that includes students, faculties, staff members, and all others. But if you're talking about a population of student, then we are going to just focus about the student itself. Yes, the population parameter is a numeric value that represents the population. So we have to define clearly what our population is. And one of the parameters that we use for population mean is mu, and the variance is sigma square, and standard deviation is sigma. Yes, after learning about sampling and about basis of probability, we are going to enter the next topic of mean, median, mode, variance, standard deviation, and so on. And most of these things you have already learned probably in your high school. Yes, that comes in handy here. And more information about this population. Yes, since the populations are quite huge, practically it is impossible to conduct an experiments for the entire population. That's one of the main reason we take a sample from the population, and for this sample we apply some statistical methods to infer what is the context of population itself. So that's the key idea about this part of exploring information about the population just by means of sample. And sample, as we know, that it contains features of a bigger population. a sample should signify the entire population rather than being biased with respect to any specific features. For example, I talked about collecting a sample of 2000 students and asking them question about do they like to eat burgers. Well, if suppose I just focus on the first year freshman students to ask the question, that is kind of biased. Or if I just focused on asking question to the students from IT college, that is again biased. So we should make sure that our sample is representing the entire population in a more fair manner. So that's another challenge of choosing the right sample that can represent the entire population. Here's an example. So you can see generalization of results necessarily adds a certain degree of error to the result. So we agree that when you take a sample and from the sample if you infer some things and if you want to apply this to the population, there is always a certain degree of error. Yeah, it is possible. Whenever you do that, you always come across these errors. Data observed in the same sample may not be same as data observed in the population. If you want to have the extrapolate this information to the population, there may be some errors. Imagine that we asked a random sample of 1000 Mexican if they smoke, and 25% say they do. If 25% of 1000 randomly selected Mexicans smokes, a simple logic would suggest that we would get the same result if we ask 122 million Mexicans. Well, it comes with an error if you go for a larger population as well. So you have to select a sample from the population, measure certain data or opinion for all individuals in the sample, and project the results we observed in the sample into the population. So this projection or extrapolation is called generalization of results. You just focus on one sample, and from the sample population, a group of people from the sample, you are actually applying it generalization. You are to the universe. You are, in other words, you are applying to the entire population. Need for samples. So there are several needs of doing sampling. Some main points are given here, like choosing a sample needs less time than choosing every item in a population. Sample selection is cost efficient technique. Yes, everybody would agree that when compared to using the entire population. Analysis of sample is less cumbersome and more practically easier than analyzing the entire population. So simple steps are given here. So we have a target population. Sample frame list is item of people that forms the population from which the sample can be chosen. So there are different sampling methods, and you also have to make sure that sample size is also quite good enough. So collect data from the sample data collections. So when it comes to sampling, how do you choose the sample population or sampling? There are different types. You can use a probability method or non-probability method. In probability method, you have a simple random sampling, systematic sampling, stratified sampling, clustered sampling. For non-probability, like convenience sampling, quota sampling, judgment sampling, snowball sampling. And remember, these are not all types. Still, people are having different other types. For example, some people just sample out based on gender, and some people want to make sure equal gender population is there, and out of every say for example when you are going out in a big community and they want to choose or take experiments in all the house, sometimes they skip every third house, and just like a sample they just skip every third house and take the information from other houses, and that is the sample data. And sometimes only odd houses are taken, sometimes the information is only taken from one house among the 5 houses. So if there is like 500 houses, only 100 houses taken. The first house is taken, the next 4 houses are left, then the next house it has been taken. There are different ways. Let's look at some of these that are given here as simple random sampling. It is a very common type where every item or individual gets an equal chance of being selected, which is quite fair. And systematic sampling is that the first individual is chosen randomly, the others are chosen with finite sample interval. Like you choose the first person and then after several interval, like you skip some people and then choose the second one, and again the same amount is skipped again and choose the other person. Just like I told you, like you take the first person and skip next 4 person and then choose the next one, skip another 4 and choose the next one. Just an example. Stratified sampling, the population is divided into subgroups called strata with respect to different qualities such as gender, category, then pick the sample from the subgroup. Clustering samples, the population is divided into subgroup called clusters, and the whole cluster is randomly selected as a sample for entire analysis. So we should make sure which type is more effective, because for certain domains certain types are good, for certain area maybe one way of sampling doesn't fit well. So for non-probabilistic sampling we have convenience sampling, which is quite easiest method because individuals are chosen with their availability and willingness to be part of the sample. Then quota sampling, the selection of item is made based on predetermined features of the population. Judgment sampling, also known as selective sampling, is done using the expert's judgment. Snowball sampling, it is suitable for population with people alone. Existing people are asked to nominate other people known to them, thereby the sample size increases like a rolling snowball. So that's about sampling. Now let's dive into the basis for probability. Well, we know that probability is like the likeliness of an event to happen. In other words, there is the possibility of any event to occur. While we toss a coin, it can turn out to be head or a tail. Both have 50% chance. Yes, head or tail. Every option has 1/2 probability. Throwing a dice, when a single dice is thrown, there are 6 possible outcomes. 1, 2, 3, 4, 5. Of course, when you throw 2 dice, there are more possible outcomes we expect. But let's consider throwing just 1 die. In that case, the probability of getting any one of them at each trial is 1/6, because there are 6 numbers there. Probability of an event happening equals probability of number of ways it can happen divided by total number of possible outcome. Just like rolling 6-sided dice, the probability of getting 4. What is the probability of getting 4? Either you can have 1 and 3, 2, 2, 3, 1. So there are 3 ways in which you can get 4. So total number of possible outcomes are 36. 6 times 6, 36. So probability of getting 4 equals 3 divided by 36. In other words, the possible number of ways it can happen is 3 divided by total number of possible outcome, which is 36. In other words, it's 1 by 12. Probability events. There are different types. We are going to just look at a few types here. The first one is the independent event. The event can be independent when each event is not affected by other event. For example, when you toss a coin, each toss of a coin is perfect unique outcome, and each trial is not depend on other trial. So that is independent event. When it comes to dependent event, and events are dependent when they are affected by previous events. We are going to look at some examples of how this can happen. So here, here it is. There are 2 blue balls and 2 blue and 3 red marbles in a bag, just like you can see here. 2 blue marbles and 3 red marbles. So what is the chance of getting a blue marble? The chance is 2 in 5, because there are total 5 marbles, right? So that's 2 by 5. Suppose after taking out 1 marble, the chance changes the next time. So if you get a red marble in the first trial, then the chances of the blue marble will be 2 in 4, because red marble has been chosen already. In case we got a blue marble in the first trial, then the chances of blue marble next time is 1 in 4. So this happens as we remove the marbles each and every time from the bag. Therefore, the next event depends on the previous events. So that's a dependent event. And mutually exclusive events, the events that cannot happen at the same time. Like for example, there are many things like when you toss a coin, you cannot get head and tail same time, or while turning left or right while driving, it cannot happen same time. Either you can turn left or you can turn right. So these are mutually exclusive events, just like XOR gate. So some notions of probability, we always refer P for referring probability. So for example, P of ace is 1 in 13 for probability of choosing an ace card from 13 cards in a poker. So P of ace is 1 by 13. Yes, there are many advantages of having probability calculation. It's very cost effective, easy to understand and implement. It gives a better chance to win any strategies, and it helps to predict the future events and avoid unnecessary delay. It's very perfect because we have the data in hand, you can clearly predict it. The types of probabilities, basically there are these 2 important types, the discrete probability distribution and continuous probability distribution. As the word discrete refers, it is a finite number or a data, and it can be counted easily, like number of students in the class or tossing a coin. These are very finite number of outcome you have. Whereas the continuous data refers to the measure of data or number that are varying continuously. For example, height, weight, time, it is a continuous event. So basically this is the probability line, it always falls between 0 and 1. So probability of event will not be less than 0 and probability of event will not be more than 0. It always falls in between. So this is one of the basic thought you can always keep in your mind. So whenever we talk about a probability for any data, it should always be within this range. So that's what we have today. We talked about population. We talked about statistical inference, in which we also talked about how sample can be taken from the population, which we refer as sampling, and there are different types of sampling available. And after we talked about the sampling, we also discussed about some basic thoughts on introduction to the probability. So as we are already embarking our journey in the statistics and probability, so in our next lecture also we are going to discuss more about like conditional probability, Bayes theorem, and Bayesian statistics. So that's what in for us in the next class. I'm looking forward to see you in the next lecture. Until then, goodbye.